Okay, this is Unit 8, Lesson 7. This is going to wrap up Unit 8, so we'll be preparing for a common assessment shortly after this. Okay, but here's what the thing is. Today we're going to continue the discussion we had about parallel lines and proportional segments. What it turns out is that not only can you just have the single situation that we talked about in the previous lesson, but you can have multiple situations where they're all proportional all the way across. Okay, so we're also going to talk about the line joining midpoints of triangle sides, which cuts it into equal pieces on two of the sides and is parallel to the third side, will end up being exactly half the length of the third side. So let's take a look and see what we got. Okay, so it starts out with that a line segment that joins the midpoints of two sides of a triangle and is parallel to the third side, and its length is going to be half of the length of the third side. So what this means is that if segment DE is parallel to segment CB, and DE is equal to CB over 2. Okay? So using that, we're going to find the values of x and y in this particular problem. Okay? So since we know that it joins the midpoint, and we know it joins the midpoint because the left side and the right side are both cut into two equal pieces by the segment that's labeled with 20. Okay, so what this means is that we can determine what this is by using the fact that we know that 20 is half of the length of whatever x plus 10 is. So we set that up algebraically as this. 1/2 of the quantity x plus 10 is equal to 20. Okay, to solve this and to take care of the fraction at the same time, we're going to multiply both sides of the equation by 2. So 2 times 1/2 is 1, so that leaves us with x plus 10 on the left. 2 times 20 is 40. So that's what our right value is. So this gives us x plus 10 equals 40. Subtract the 10 from both sides, gives us x is equal to 30. Okay, since the two segments on the right side of the triangle are congruent to each other, and we know that because there's a double tick mark on both of these, so that means they're separated by the segment that's labeled 20 at its midpoint. So this means that 2y plus 16 is equal to 4y plus 6. So this is our equation. And what we're going to do is we're going to move the 2y to the left side, and we're going to move the 6 to the right side. So this gives us 4y minus 2y equals 16 minus 6. So this simplifies to 2y is equal to 10. Divide both sides by 2, and we find that y equals 5. Since this is all they ask us to do, this gets what we're looking for. Okay? Now the thing is, they could have asked us to find what the length of that side that's represented by x plus 10 is, so we would have substituted the 30 back in for x and found that its length was 40. Or they could have asked us what the length of either one of the two segments or both of them were, so that we would have substituted the 5 back in for y. Okay, wouldn't have mattered because we could have substituted it into either one, and we would have found out that it was going to be 26. Okay, so let's take a look at this. The converse this is the extension that I was talking about from the previous lesson. In the previous lesson we talked about one line that was parallel to the third side. Okay, so this time we have several parallel lines that are intersecting two transversals. Then the transversals are cut into proportional segments, and it would look something like this. As you can see, it's basically a triangle that has not been completed out, but what this is useful for is it's useful in real estate to set up what lots are going to look like between two streets. It's also used to determine what the rental would be in something like a mall, like Parks Mall. That's why you'll find some stores there that have a very narrow front, because they pay less based upon the frontage that they have going into the mall. The wider it is, the more advertising they can be on display with, and so consequently that's why they get charged a larger fee. Okay, so let's see how this works. So this tells us that AB to DE is equal to BC to EF, which is equal to AC to DF. Okay, so that's what we have. So you can mix these together. So you could say AB to DE is equal to AC over DF, or you could say BC over EF is equal to AB over DE, or any combination of these. And you can also interchange the means like we talked about earlier, which is then this, what we're talking about here is on a diagonal in the equation you can exchange the values. Okay, so basically what they're saying is you can exchange the means or the extremes, either one. Okay, so let's see what we can do to find x in this problem here. Okay, so what we've got is we've got this diagram. So that leads us to this proportion, which we're going to have 11 to x is equal to 8 over 7. We're going to cross multiply, which gives us 8x is equal to 7 times 11, which leads us to 8x equals 77. Divide both sides by 8 gives us x is equal to 77 over 8. Alright, example 3. This time we have two variables to find, x and y. So let's take a look at what we have for our diagram. In our diagram, this is a little bit more complicated. As you notice, you have x, y on the left side and a 3. And on the right side you have 2y minus 18, x plus 4, and 4. Okay, so let's see what we can do. We need to find x and y. So what we have here is 2y minus 18 over y. Notice that they're relating these two values here directly across the figure is equal to 4 over 3, which are the values that we have numerically. Okay, once again we're going to cross multiply, so this gives us 3 times the quantity 2y minus 18 is equal to 4y. Do our distribution, gives us 6y minus 54 equals 4y. We're going to simplify this by moving the 4y to the left and moving negative 54 to the right. So this gives us 6y minus 4y equals 54. So 2y equals 54. Divide both sides by 2 gives us that y equals 27. Okay, now we have to find what x is. So we're going to set up a similar proportion. So this is going to be x over x plus 4 is equal to 3 over 4. Once again we're going to cross multiply, so this gives us 3 times the quantity x plus 4 equals 4x. Do our distribution, 3x plus 12 equals 4x. We're going to subtract the 4x from the left side, and we're going to subtract the 12 from the right side. So, or actually we moved it the other way. We moved the 3x to the right, so it'll work either way this way, just so long as we get the numbers on one side and the variables on the other side. So 12 is equal to x. Okay, another theorem says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So as you notice here in the diagram that they're using to illustrate this, is telling us that all the values of this side over here are 5, and one of these is 6, so we could actually say that all of these are 6. Okay, so BC is equal to 6 and CD is equal to 6. Okay, so this time we have x and y that we need to find, and here's our diagram. It's a fairly complicated one, but notice that on the right side here, all of these segments that are being cut by the parallel lines in this transversal are congruent. They're all congruent because they're all marked with a single tick mark. So this means x plus 2 has to equal 2x minus 4. So once again we're going to combine like terms. So we're going to move the x to the right, and we're going to move the 4 to the, or actually the x to the left and the 4 to the right. So this gives us 2x minus x equals 4 plus 2. So x is equal to 6. Similarly, we can say that y plus 6 is equal to 7y minus 6. So we're going to move the y that's on the right side, we're going to move it to the left, and we're going to move the negative 6 from the left side to the right side. So this gives us 7y minus y equals 6 plus 6. So this gives us 6y equals 12 when we simplify, and y is equal to 12 divided by 6, or 2. Okay, this completes lesson 7. Once again, make notes of any kind of problems or questions that you've got regarding any of these, and I'll see you tomorrow, and we'll be glad to discuss these before we start any kind of work. See you tomorrow. Thank you very much. Good night.